this video. Today, I would like to solve a geometry problem that took me a lot of time to solve for no apparent reason. A little bit of backstory on this problem. This problem was created by Katrina Ad, which posts a lot of geometry problems on her Twitter profile, which I'll link in the description. And as I said earlier, this problem took me a lot of time to solve, probably because I did a lot of calculation mistakes for some reason. So let's take a look at it. We have a rectangle ABCD and another rectangle AECF, and we're giving those three side lengths, namely AB is equal to 5, AF is equal to 7, and AE is equal to 1. And we want to find out the measure of theta, which is angle AFB. So let's get right into it. I would first like to name this point G and this angle alpha. So this angle will be pi over 2 minus alpha, because the sum of angles in a triangle is pi radians, or 180 degrees. And then these two angles are vertical, which means they will have the same measure, and this will also be alpha. Okay, so now we have two similar triangles in which we can compare the tangent of alpha. So in this triangle, it'll be GF over 1, which is just GF. And in this triangle, it'll be GB over 5. Multiplying everything by 5, we get that 5 times GF is equal to GB. And now we will call GF to be A for simplicity reasons, because I don't want to write GF over and over again because I'm lazy. So our GB will be 5A, and our AG, well, AF is 7, so AG will be 7 minus A. And now we have a right triangle in which we can apply the Pythagorean theorem, and that's what we're going to do to solve for A. So this squared will be 25A squared plus 5 squared is 25, will be equal to A squared minus 14A plus 49. If we bring everything to the left hand side, we'll get that 24A squared, and my 4 looks a bit like a 9, 24A squared plus 14A minus 24 equal to 0, which means that dividing everything by 2, because 2 is not equal to 0, so we get 12A squared plus 7A minus 12 is equal to 0. So now we can use the quadratic formula to solve this. So we have minus 7 plus or minus square root of 7 squared minus 4 times 12 times minus 12 over 2 times 12. So now we have minus 7 plus or minus, evaluating the square root will give you the square root of 625, or simply 25, over 2 times 12 is only 24. And now I would like to notice that we are in Euclidean geometry, which means that since A is a side length and side lengths cannot be negative, we'll have to ignore the minus sign here, which means that our A will be 25 minus 7, which is 18, or over 24, which is 3/4. So now 5A will be equal to 15/4. 7 minus A will be 25/4. A will be 3/4. So now we'll get some trigonometric values for alpha. So we know that the tangent of alpha is exactly that, A. So this means that the tangent of alpha will be 3/4. And then, let's see. These two triangles are simply scaled versions of the famous 3, 4, 5 triangle. For example, this one, multiply everything by 4, we get 15, 20, 25. Divide everything by 5, we get 3, 4, 5. This means that the sine of alpha will be 3/5, and the cosine of alpha will be 4/5. So now we will only focus on this triangle ABF. So let me just erase this. Okay. And we draw this triangle. So this little squiggly line here. Okay, and we'll draw this. Okay, so we have A, B, F, and G. We have alpha, theta, 15 fourths, 5, 25 fourths, and 3/4. Okay, so I would first like to find the length of BF, because then if we know all the lengths of our triangle, we can apply the law of cosines to find out what theta is. So I would like to add this thing, which is the height and extension of the base. So we'll call this extension of the base to be x and this height to be h. So now, let's see, the sine of alpha will be, well, it's already 3/5, but it will also be equal to h over the length of AF, which is 7, which means that h will be 21/5. So this is 21/5. And the cosine of alpha will be equal to 4/5, but will also be equal to x plus 5 over 7, which means that isolating x, we get x plus 5 equals 28/5, or x equals 3/5. So we will substitute those lengths in 3/5 and 24/5. So now again we have a right triangle in which we can apply the Pythagorean theorem. So we'll have that BF will be the square root of 21 squared over 5 squared is 441 over 25, plus 3/5 squared is 9 over 25. So this is the square root of 450 over 25, which is exactly the square root of 18, or 3 times the square root of 2. Okay, so now we're ready to finish this off by applying the law of cosines. We'll just erase this to make some more space. Okay, so we have that our length AB squared, which is 25, is equal to AF squared, or 49, plus BF squared, which is 18, minus 2 times 7 times root 2, which is 42 root 2, times the cosine of theta. And now 49 plus 18 is 57, and 57 minus 25 is 42. So we will get that 42 root 2 cosine theta equals 42. We move the 42 root 2 cosine theta to the other side. And the 42s will cancel out, provided of course that 42 is not equal to 0, which it is, not equal to 0. So then the cosine theta, dividing both sides by the square root of 2, we get 1 over square root of 2. Rationalizing the denominator, we get square root of 2 over 2. And now, let's see. ABF is an obtuse angle, which means that BAF and AFB will be both acute angles, which means theta will be an acute angle. And let's see on the unit circle, the unit potato. The unit potato, wow. I just discovered the unit potato, I'm smart. Okay, so this is the cosine, this is square root of 2 over 2. It's already swan. So since our theta is acute, it will be in the first quadrant, which means it will be this point here. This is root 2 over 2, and we have an isosceles right triangle, which means that this angle right here will be pi over 4. Therefore, theta equals pi over 4. Oh, that's a nice answer, as always with Cauchy and Ag's puzzles. And that's the end of the video, so thanks for watching. Don't forget to like, share, and subscribe. And I'll see you in the next video. Bye!